class 11. In our yesterday's class, we have seen the numerical based on the molar volume. Okay, now today we are going to see percentage composition. What does percentage composition means? So the definition tells us percentage composition of a compound is the percentage by weight of each element present in it. So in any compound, the elements that are present, in what percentage, we call this as percentage composition. So it can be calculated by using this formula. Percentage of an element in a compound will be equal to total weight of the element in one molecule divided by gram molecular weight, or we call it as gram molecular mass of the compound, into 100. So when you use this formula to calculate, you can get the percentage of an element in a compound. So we'll see the numerical based on it. Say for example, the percentage composition of both hydrogen and oxygen in water can be calculated as, so we have got this formula, mass percent of element is mass of that element in a compound divided by molecular mass, or we call it as molar mass of the compound, into 100. So when you calculate the molecular mass or molar mass, it will come as 18. Okay, remember that it will come as 18, or over here it is 18.02, since the weight of the hydrogen is taken as 1.008. okay, now you can take simply 1. If you take 1, it will come as 8 gram. So for mass of hydrogen in water is, in water we have got 2 hydrogens, so 2 into 1 is the atomic mass of that element, 1.008 divided by 18 we can write, or 18.02. so when you multiply it by 100, it will come as 11.18%. so mass of hydrogen percentage in water molecule is 11.18%. Similarly, mass of oxygen we can calculate. Mass of oxygen will be 16. Why it is 16? Because we have got only one oxygen atom and the atomic mass is 16. So 16 into 1 divided by 18.02, or you can write 18 into 100, that will come as 88.79. So this is how we can calculate the percentage composition of the elements. I'll see you one more example. Okay, this one. Calculate the percentage composition of Epsom salt, which has got the formula MgSO4.7H2O. So here also the first thing is that we need to find the molecular mass of the compound. So the molecular mass of the compound, atomic masses are given: magnesium 24, sulfur 32, and oxygen 16, hydrogen 1. So when you find the molecular mass for MgSO4.7H2O, it will come as 246. Fine. Now you have to find the percentage composition of Epsom salt, means you have to find the percentage of individual elements. Say for example, percentage of magnesium, sulfur, oxygen, and hydrogen. So first, percentage of magnesium. So magnesium over here in this formula we have got only 1. So 24 is the atomic mass into 1 divided by the molecular mass of the compound, 246 into 100, which will come as 9.75. Similarly, percentage of sulfur is 1, so 32 into 1 by 246 molecular mass into 100, which will come as 13.01%. Similarly, percentage of oxygen is, we have got how many oxygen atom we have to count? 4 over here and 7 over here. So 4 and 7 altogether makes 11. 4 and 7 altogether makes it 11. Okay, sorry. Over here you can just consider this oxygen as a separate element and water as a individual. Okay, water as a different molecule over here. So over here we have got 16. We have got 4 oxygen atoms, so we have taken it as percentage of oxygen as 16 into 4, that will come as 64, by 246 into 100, that will come as 26.02. Now this one, percentage of water, for 1 molecule of water, if you find the molecular weight, it is 18. So 18 into 7, which will come as 126, by 246 into 100, which will come as 51.22%. Now when you add all these percentages, it will come as 100%. So this is how we can calculate the percentage composition of Epsom salt. So in a similar way, your today's assignment number 6 will be question number 1. Calculate the percentage composition of various element in Na2CO3, that is sodium carbonate. atomic masses of sodium is 23, oxygen is 16, and carbon is 12. Then calculate the percentage composition of ethanol, C2H5OH. Now over here we have got carbon 12, hydrogen 1, and oxygen 16. Now over here you can consider the hydrogen together, since it is a single molecule. We don't have H2O like that. So you can consider 6 hydrogen at one time. Question number 3. Calculate the percentage of water of crystallization in blue vitriol. That is CuSO4.5H2O. That means in this you have to find only the percentage of these 5 molecules of water. So this is today's assignment. What you can do is the 2 questions that I have given you yesterday in the numerical form, calculation based on the volume, you can add it over here and send it to me. Okay, so I'll give again a link will be provided to you where you need to submit your assignment, today's assignment 6. So complete this and send it over there.